Hey folks, good morning. We are going to start off with the first talk of the day today. We have Aaron talking about Lex Sleuther, a novel approach to script identification. Reminders, if you have questions, please log into Slido. The codes should be in your programs. We will be taking questions only through that as we go through. And now over to Aaron.
Thanks, everybody. Talk check, talk check. There we go. All right. So good morning, everybody. Thank you for coming. I've got quite a bit to go through today, so the pace is going to be a little bit fast. Everything will be published at the end, and of course, you can find the recording later. I'll try to leave as much time as possible at the end for questions. If we end up going over, I'll let you know where to find me afterwards as well. Welcome, as you said, to a novel approach to script identification. If you haven't heard those words in that order, stay tuned. The tool that I want to show you is called Lex Sleuther. And some of you might be able to guess how it works based on just the name, but if so, keep it to yourself. Spoilers. Who's responsible for this? My name is Aaron James, and I like to build weird things and talk about them. I've been coming to this conference for 3 to 4 years, but this will be my first time on this stage, so thanks for having me up here. I do security research for the threat intelligence team at CrowdStrike. They're like a little security startup. They have a booth at RSAC. You should go check them out. And they pay me to build cool tools to support threat analysis at like massive scale. And that's basically me. I'm the cool tool guy. You can find me on GitHub, but it's pretty sparse these days. Having a full-time job will do that. If you want to come and find me after the talk, I plan to oscillate between the CTF room and the bar. Just be warned that I will be busy winning. With that said, let's get into it. Quick, what is this? Anyone know? Hey, okay, great. We're all at the same conference. This is VirusTotal. You submit a file, you get analysis aggregated over multiple sources. It's a little bit of an open secret that every security company that does malware analysis has some version of this, right? Some internal pipeline that automates this at varying degrees of scale. And based on how VirusTotal is organized, you might think such a pipeline looks like this. You submit a file, which is then processed with distinct dynamic analysis components. Let me actually go here, which independently produce structured data. But this is inaccurate, right? It really looks like this. Static analysis is a prerequisite to dynamic analysis, effective dynamic analysis, right? They inform each other. Often the success of your dynamic analysis hinges on the success of your static analysis. Here's an example. It could come to very different conclusions about the type of file being processed, right? There is no one dynamic analysis engine that is going to handle all of these cases. And beyond that, each of these cases might need to be analyzed in a completely different environment, which means if our static analyzer gets the file type wrong, then dynamic analysis is also unlikely to yield anything useful. I don't want to oversimplify the file type decision in and of itself either, right? It is certainly true that distinguishing a binary file from text is basically free. And it's also true that static signatures available for identifying binary formats are kind of robust. The tricky part, though, here is scripts, right? If we don't have the name of the file, if we don't have the file extension, what tools are at our disposal to tell PowerShell from, say, Bash script? That's a rhetorical question. If those were our only two options, right, we could probably come up with a simple heuristic, but unfortunately, malware is a diverse genus. If you pick randomly, you're probably going to get it wrong. If you detect the wrong language, not only do you not get execution, but you wasted time and money, and the failure itself is difficult to detect. How you distinguish between an incorrectly identified script and a script that's plain broken is not obvious. Fun fact, most malware is broken. And the answer is you at least hope that the script decision part was right and the rest of your pipeline is working correctly. This conundrum is what Lex Sleuther tries to address, right? It takes in your file as input and tells you what script language it's in. Now, I'm not coming up here to pretend that Lex Sleuther is the only tool that does this. There's actually heaps, which is why I'm going to briefly go over the main contenders. For example, what about LiveMagic, right? That's the de facto standard that's been around forever. You run file on Linux and it tells you what it is. To keep this part short, it's a suite of static signatures that is excellent at identifying most binary formats, but is poor, let's say, with script languages. Its signature spec just is not the right architecture for freeform text at all. And it can catch some easy cases, but as you can see in my n=1 example, it is too prone to false negatives to be useful in this context. What about Yara rules, right? Well, the main problem is you write them yourself and maintain them for all of eternity. And this is a recipe for some very unpolished heuristics. Rules like this one tend to, let's say, overachieve in the wild. And I know what you're thinking, right? Surely this is a contrived example with made-up numbers, right? So in summary, Yara rules are the wrong tool for the job. Using them to identify script languages is like using a hammer to drive a screw. You can get surprisingly far with it, but you really should go find that screwdriver. Here's the screwdriver, right? GuessLang is a deep neural network with a linear classifier. And as you can tell by the GIF, maybe, oh, nice. It supports, it's used by VS Code. And it supports over 100 languages, which is actually kind of a bad thing for our context. We'll talk more about why later. And it's also not nearly as portable as the other options. It uses a lot of resources and is not suitable for constrained environments. And in fact, a study done at CrowdStrike found that GuessLang was more accurate than our stitched together heuristics, but was also 1,000 times slower, which we made the call that the 6% boost was not worth it, and we kept looking. Now, if everything we've been looking at so far is the black and white portion of the infomercial, what we've got for you next is the magic tool that will breathe color back into the universe. It's Lex Sleuther, right? No, the last word is magica. You see, early last year, Google used its bottomless ad money to summon the top minds in artificial intelligence and unified them, the Avengers team, to fixate on one goal: GuessLang but good. And honestly, they killed it, right? It supports every binary file type of LiveMagic and every text file type of GuessLang. It can infer both at over 99% accuracy in under 5 milliseconds per file. The model that does this is small enough to fit on a floppy disk. How did they accomplish this? Honestly, it's not that complicated, but it is out of the scope of this talk. So if you are interested in it, please go read the paper. It's short and sweet. And it's also worth mentioning that, Google only created this project to improve a service of theirs called VirusTotal, right? So, which of course exists primarily to scan Gmail attachments, which in turn only exists to harvest user data for ads. So really, it's just ads all the way down. But I mention this because this is what Google did to solve this exact problem that we're solving. So if Magica is so great, why build something new? Well, first of all, Magica was first released in February of 2024. Lex Sleuther started development in 2023. In other words, it didn't exist, just being completely honest with you. And if it did, maybe this talk wouldn't exist either. But I have other reasons, okay? So second of all, Magica does have some weaknesses, which I will show. And I promise I am not huffing the copium. I have concrete examples. And then third, it's fun, right? Building things is awesome. While it is true that perfect can become the enemy of good, right? It's also a shame to let good enough be the enemy of better. Better put, good enough can sometimes create holes. Let me show you what I mean. Here's some numbers from CrowdStrike with permission. In our pipeline, only 8% of the files coming in are entirely text files. And then on top of that 8%, less than 1% of those are executable scripts. Of that 1% of 8%, CrowdStrike can classify scripts with, around 90% accuracy. That should be good enough, right? Well, that's the funny thing about scale. This first number is 2.6 million per day, which means we're processing at least 212,000 text files, and even if only 1% of those are executable, that's still 2,000 scripts. Even at 90% classification accuracy, we're missing out on hundreds of scripts per day that are completely invisible to us. Those last few percents end up being a big problem. That gap is worth trying to close. And this begs the question, do we stand a chance at creating something better than 90% accurate? I believe that the answer is yes, and I think we can get it done quickly and easily. Here's why. Most of these open source projects that I've talked about support hundreds of file types and languages, but in our use case, we're only interested in about 5 or 6 languages for our pipeline. These. We can probably create a solution that's more effective than the state of the art by just focusing on these languages only, right? A novel approach can often address gaps when combined with an existing system. Narrowed scope is in and of itself a privilege. So let's brainstorm. I mean, let's really just throw stuff at the wall here, as long as we throw stuff in the context of the problem that we're trying to solve. Remember this diagram? Here's an idea. Instead of trying to figure out which script runtime to use them all. Instead, just send every script to the same dynamic analyzer. And then once the script is in this virtual machine, just execute the script with every known scripting language. Start 6 processes, monitor them all. Probably only one of these processes stands a decent chance at executing correctly, and the rest will all error out. But at least you're much more likely to get execution, which was kind of the point to begin with. As I'm sure you might be able to tell, there are a few problems with this approach. The big one is that we now have to trace 6 processes instead of 1 simultaneously and kind of disambiguate which one was successful, and how to do that is not obvious, and then pretty soon you're trying to solve that problem instead of the original problem. Maybe we get lucky and it's simple though, right? So what would happen if we tried to execute a PowerShell script with Python? Well, usually we would get like a syntax error like this. And that gives me an idea. What if, instead of trying to run the script with 6 different runtimes, we run the script through 6 parsers instead? These parsers won't execute anything, they just tell us if there was a syntax error or not. Surely the parser that doesn't error out is the correct script runtime to use. And there are still issues with this idea, but something like this is at least feasible for a small project. Some of these parsers are very obtainable. Some are not. For example, for something like Microsoft Batch, the implementation is the language standard, and writing our own batch parser also feels a little in the weeds. We're getting lost in the sauce here, right? We need to be less clever about this. We don't need to generate abstract syntax trees or do incremental parsing. We just want to know, does this file contain tokens characteristic or uncharacteristic of, say, a Python file? And you don't have to open your Dragon book, sorry about the blinding, to know that parsing is complicated. So let's do as little as possible, right? Let's just focus on the first step. We said we only cared about the tokens, so what if we only did the lexing part? How hard could it possibly be to write 6 lexers? I know that sounds rhetorical, but honestly, I think it would be pretty easy if we use like a lexer generator. Oh no, I found one on crates.io. Oh look, it uses Rust proc macros, so the syntax is easy. It's just like writing formal peg. Oh no, I'm suddenly writing a lexer in Rust proc macros. If I'm not careful, I'll accidentally write 250,000 lines of expanded code in less than 12 hours. Oops, we just built Lex Sleuther, also known as I wrote 6 lexers and stapled them together. And the trademark is not pending on that, by the way. That sounds cool, but I hear you asking, how is it useful for us to do this? Let's take it from the top. We can now create token streams from an input file. Through a process that is still a mystery, we want to take those token streams and produce a set of, say, scores correlating with how likely each language is. Then we'll just pick the high score to decide on a verdict. The only missing piece here is the middle bit. We get that and we're done. So let's try something simple. We do not have to get into like data science here. We do not have to come up with something brilliant. It can be dumb, and it might be. So taking things from the top, let's say we have some Python, don't worry about what the code does, as our input file. This is what happens when it goes through our Python lexer. Ooh. Look, you like that? I can go back too. It goes backwards, it goes forwards. That's so cool. Anyway, I love PowerPoint. Now, there's a lot of information here that might be useful for scoring, but in the interest of keeping things simple, let's just throw most of it away and just count token type. I said dumb, right? all of these token counts make up some long vector. And this isn't just Python tokens, but also token counts from the PowerShell lexer, the HTML lexer. We lex that file with all of them, right? And they're all concatenated into one vector. That is our input. And then our output is those 6 language scores. Sorry about the math notation. Now, we know that if our input is m rows in one column and our output is 6 rows in one column, then we know that any linear relationship between them can be modeled by a 6-row m column mystery matrix. And I'm afraid I have tricked us into doing linear algebra. So this isn't just hand waving, right? There's an intuitive definition for each of these weights. Quantitatively, how much does each token contribute to each language verdict, right? We need to figure out our weights. We can't just pick random numbers. I tried. We need to mathematically derive them, which we can do if we create the inverse system like so. Now, focusing on this system, to derive the weights for a single row of the matrix, we would need to ingest a corpus of files, and then we would populate the system where each row is all of the token counts for a single file. Then we would assign ideal scores based on the expected verdict. We just make up the convention of 0 and 1 here, but we could have used anything. And then the only unknown here is that weight vector, which means we are dealing with a textbook AX equals B linear system. Provided that n, the number of files, is strictly larger than m, the number of tokens, the system is overdetermined, and we can just use linear regression to compute optimal weights. Most linear algebra libraries can do this in just a few lines of code. You can call this machine learning if you say something like, oh, it's a feed-forward neural network with 0 hidden layers. I just call it pre-calculus. This approach does require you to have a corpus of pre-classified files to train with. I wrote a helper script that lets me preview text files and classify them using my numpad. I can drink my coffee with my other hand. The script is called LSD, which stands for Lex Sleuther Dataset. And while I'm using LSD, I can classify about 1,000 files an hour, so it's sometimes just a good way to relax. Once that's done, and we've trained our model with it, we can start using it to issue verdicts. And to make all this useful, I gave Lex Sleuther a CLI as well as Python bindings, publishing pending. It's designed to have a usage that closely resembles the GNU file utility. And in fact, we can compare the results of those side by side. For the small example folder that I showed earlier, it seems to be working, right? It manages to get them all right. That bodes well. And then just as a reminder, this is what LibMagic reported for the same data set. Well, in my mind, this is a huge win. Our solution wasn't all that clever, but we're off to a good start anyways. The next step here would be to evaluate performance over a much larger data set, right? And thankfully, we can already do this with the help of our old friend LSD. With this single command, we can compare accuracy between Lex Sleuther and, in this case, File ID, which is CrowdStrike's legacy classification system powered by LibMagic and Yara rules and staples. This will tell us how close we are to achieving 90% accuracy. Here's what it says. Oh, well, whoops, that's unexpected. So turns out we're done, actually. It's good enough. And I think it goes without saying that we can already prefer Lex Sleuther over File ID. And I don't want to, understate it. This is a great result, but I mean, still, is there any reason to prefer this over something like Magica? Seemingly, no. Magica is very, very, very good, right? The head-to-head is not favorable here, but this is a good example of how evaluating different tools can get a little complicated. Scope, again, right? Narrowed scope is a privilege. Why did Lex Sleuther's accuracy go down here? That's because this is comparing accuracy over Magica's supported file types, all 200 of them, right? Lex Sleuther only supports 6, so it's going to give a wrong answer for anything that's not one of those 6. If we limit our analysis strictly to the 6 file types that Lex Sleuther supports, the numbers tell a slightly different story. In these cases, Lex Sleuther is competitive with Magica on accuracy. But a more revealing metric is the false negative rate. See, lower is better here. This is a metric by which File ID is laughable. Magica is an order of magnitude of improvement, but interestingly, Lex Sleuther manages to be even better. And the way you can think about this is they're both pretty likely to get it right, but Lex Sleuther is less likely to get it wrong. Glad we cleared that up. So remember this diagram from earlier? Who won, right? Does CrowdStrike end up using Magica or Lex Sleuther to fill in that mystery component? The answer, of course, is yes. The truth of the situation is that we use everything, right? LiveMagic, Yara Rules, Magica, and Lex Sleuther to draw conclusions about what dynamic analysis engine to select. Any mature classification system needs that big, ugly block of business logic that makes decisions. Maybe it's, I don't know, just, maybe it's a 1400 line if-else statement, You can call it that if you want to. I call it the synthesis selector when I'm feeling sophisticated. And by carefully interleaving these heuristics and tweaking their evaluation order, you can create a very intelligent decision engine that has the best features of its parts, but is also easily maintainable, meaning that if there's an edge case, you can easily insert a new rule to remediate it. You can prioritize other tools in specific cases, and you wouldn't have the ability to remediate if you just slapped Magica or if you just slapped Lex Sleuther on those things. But all of that is unnecessary detail. The bottom line is, in the context of CrowdStrike, the presence of Lex Sleuther in this system boosts our dynamic analysis efficacy of script samples to 97%, which is pretty good. And if you want to try it, as of this talk, well, actually, as of 5 minutes before this talk, I had a little bit of trouble. Lex Sleuther is now open source, so you can go check it out. If you are the kind of person to pipe curl into Bash, you can cargo install it and run it right now, and use it to tell you if a file is one of the 6 file types. I mean, it's kind of a limited tool, but we're putting it out there because I think its approach is unique. And that is all I had to talk to you about today. Thanks for having me. Thank you.